Welcome everybody to the Calantic booth here at RSNA 2023. We could not be happier to have you here with us at the Bayer Digital Solutions AI Visionary Theater as we welcome a powerhouse lineup of developers, experts, and thought leaders, bringing you visionary discussions designed to give you insights and inspiration to ignite your AI strategy. All right, let's go ahead and jump in with our very next speakers here to discuss streamlined medical image boost processing, post-processing toolkits for neuro-oncology. Please welcome COO Timothy Dondlinger from Imaging Biometrics, as well as our own Stephen Blummer from Bayer. Thank you so much. Round of applause, guys.
Test. Thanks so much. My name is Steve Blummer. I am the America's Director of Radiology Digital Medical Affairs at Bayer, and I'm excited today to be talking with Tim Dondlinger of Imaging Biometrics. He's the Chief Operating Officer for the company. So why don't we get started, and just quickly, Tim, why should people adopt your application?
Thanks for asking, Steve, and thanks for the intro, Brian. We're going to focus today on a couple of our modules in our IB Clinic Toolkit, specifically the IB Delta T1 and IB Neuro. You asked why people should adopt these. There are really a couple of different reasons for each of the two modules. The first one, in the case of IB Delta T1, is it's all about speed and accuracy and precision. It's designed to take our standard of care pre and post T1 images we would acquire normally during a standard acquisition for a neuro-oncology patient and address the questions of, okay, what's really enhancing here in this image? So when we don't have a clear, obvious answer to that question, our Delta T1 can help fill that answer for them. And then IB Neuro is our flagship product that's designed to analyze DSC Perfusion images. And what that does is that helps answer the question, once I know what that enhancement is, what's really under the hood there? What's going on for that patient? Is it true tumor advancement, true progression? Or is it a post-treatment radiation effect, or pseudoprogression, or some other non-disease phenomenon?
Thanks for that. Those are both, as a practicing radiologist, I can tell you that those are both very important questions that need to be answered sometimes and can be quite confusing. So you touched on this a little bit, or at least you alluded to it, but what are some of the indications for use?
Okay, so our products are designed for processing virtually any adult type neuro case. Again, we're focused in the neuro-oncology space. We take T1 pre and post contrast in the case of Delta T1, and we use a standard DSC Perfusion acquisition that can be used from any scanner, any manufacturer, sorry folks, GE, Toshiba, Philips, you name it, we'll be able to process any of those. And so what they do in the case of the Delta T1 is it creates that comparison image showing us where those true enhancement regions are. And in the case of IB Neuro, it provides for us a variety of perfusion maps, primarily for neuro-oncology, the RCBV maps, but we also have stroke applications as well. We can do cerebral blood flow, Tmax maps, things like that.
Excellent. So next thing, why don't we talk a little bit about how this fits into a clinical workflow, and also if there's been any validation.
Okay, first of all, the standard workflow is very straightforward. As I mentioned, we start with the standard of care. We take our pre and post contrast T1 images. The only catch is those images have to be acquired the same way. Some clients like to turn on fat saturation for one, but not the other. Unfortunately, for the Delta T1 application to work correctly, we have to have the scanner settings the same for both the pre and post set of images. Once those images are acquired, we send them right from the scanner off to the Calantic platform. IB Delta T1 does its thing, and you get the difference map output with the true contrast region highlighted in orange. As one of the clinicians we have who started using this when we first developed it, put it, we do more of this and we're going to be putting him out of business. Obviously he was joking, but nevertheless this does make it obvious that even a non-expert like myself can help identify what those true enhancing regions are. In the case of the IB Neuro, that's our DSC Perfusion application, There we use, again, a standard DSC T2 star weighted scan. Again, any vendor, 1.5T, 3T. I don't know of anybody who's experimenting with it in 7T, but it should work there too. So again, we process the scan, we acquire it. We're one of the few vendors that can actually accept different types of DSC scans. And then those again off to Calantic, off to IB Neuro, and you get the maps that you have pre-selected as outputs from that system.
And what about validation?
Validation actually dates back to work that was done in the mid-90s by our founder. The IB Neuro algorithm is something that she did work on back at Harvard and MIT, at Massachusetts General Hospital, and it has been used in cases since then, numerous studies throughout the world. It's one of the few that's used in global multi-center trials. It's been validated against other tools and has consistently come out on top in terms of its performance. It's been compared with actual histologic samples. It's been, as I mentioned, compared against other products, and really does a fantastic job.
Excellent. I believe, oh, yes. In terms of clinical impact, you've alluded to some of that as well, but I guess let's just go through some of that one more time for the listeners.
Again, if we start with the Delta T1, this one, as I mentioned at the very beginning, is all about speed. And what we do with this tool is it makes it very simple, very straightforward for a clinician who's faced with trying to compare two somewhat potentially confounding images and answer the question, okay, in here, what's really enhancing and what's not? What we found is that we have clients using it in tumor board, so that there are no arguments, there's no discussion. It's simply throw it up on the screen and everybody knows what it is we're looking at, what the true area of concern is. One of the things I neglected to mention is that these maps are quantitative as well, which makes it very easy and straightforward to determine the volumetric quantifications of those enhancements regions. Again, that's a feature that's only present in IB Delta T1. In the case of, once we know what that enhancing region is, then we're back to that question I mentioned earlier, which is, okay, what is that really? Does it reflect true disease? Is it progression, regression, or is it some sort of treatment effect? Post-radiation, tissue necrosis, pseudoprogression. IB Neuro, through our RCBV map, helps answer that question, providing that information to the clinician. One of our, a more recent quote is one of our users has said, you know, I really couldn't tell for sure what was going on with the pre and post contrast, but the Delta T1 says it all. We also have clinicians anecdotally who have used IB Neuro to help answer the question, where should we be biopsying? Where should we be focusing our radiation for the rad-oncs? What should we be doing in terms of ongoing treatment? Is this patient progressing? And for better and worse, we have anecdotes of both ways where patients have been taken back for additional resection and finding out that when they looked at the IB Neuro RCBV map, that it really wasn't necessary. Conversely, we've had patients who unfortunately expired, but when you look at what the IB Neuro RCBV map showed you, they really did have progression that could have been treated.
Interesting. Well, I think that's all the questions that I have. Does the audience have any questions?
Nice microphone for any questions.
Don't be shy. Guess that's it.